If you've been using agents long enough, you've dealt with compaction. It's something that is really unavoidable. It's a part of how these agents work. And it's our job as engineers or designers to figure out solutions and systems to best utilize that context window and compact when necessary, however necessary. That often leads us to the question, what is the right kind of compaction? Are there multiple kinds of compaction? And can we start finding definitions and terms to use? Because ultimately, every domain is different that uses these agents. So is every harness that you use might require a different set of compaction rules and systems to think about. So that's why I've started to really think about Einstein. Now, I feel like there's probably a million videos out there that talk about Einstein in one way or the other, whether it's a metaphor or some hyperbolic statement about genius. But Einstein, to me, when I always think about it, I always think about his messy desk. I'm somebody with ADD, and you can't see this desk here for a reason, but it gets messy. And maintaining that desk is difficult. It requires systems. It requires, I have a mug for my markers, right? I have a jar for my thumbtacks that I don't use. And then I have like a bag of chips here. It can get messy at times, but there are certain levels of organization that we use. And Einstein was somebody who had no systems at all. And for somebody that was a total genius, he sat at that desk to some capacity every day and had to work through that pile. Context windows aren't much different than a desk. You're managing all these different facets of a finite space, your MD files, all your things are going to clutter that space however they're used. When you write that Claude MD file at the root, it's going to be in every single instance of the context window. It's like pasting it right on that desk. This is not moving. So I kind of call this thought exercise the desk of Einstein. And how do you manage Einstein's desk? Working memory is sort of a foundation for how we think about what's in the context window at a given time. Especially when it comes to compaction, where usually we're compacting due to logs of memory over time. Therefore, that working memory is really the most important when it comes to compaction, because how do we compact tool calls after reads, after writes? We have to essentially manage that ongoing log and that working memory and then decide when our desk is too full. There's a few different ways we can think about it. First is summarization. So if I get enough items on my desk here, like Einstein, I can create summaries as I go and then just toss out the rest, right? Wherever you might toss it, you could toss it into a session log, you could toss it into a RAG system. But the point being, I'm putting all of the actual raw data aside and I'm using generated summaries to keep track of what happened. And in this case, if it was Einstein, he has to write down a summary of exactly what happened, put it in a pile, and then manage the pile on top of just throwing out the rest, right? What summaries stay in context? What summaries can be tossed out? How do we manage those summaries separately from the raw session data? Summaries are how most harnesses are doing compaction today. Claude Code, Codex, almost anything that requires a long horizon task is using summaries for compaction. It's efficient, it's good at retaining semantic continuation, meaning when I have to compact because I can't keep going, it's easy to pick up where it left off because it can say, hey, at compaction, we're going to summarize so the next agent or the next session can pick up where we left off. It does mean, however, there is a loss. Exact wording or phrases can be lost in the mix. When we're distilling down to a few bullet points, it might be hard to retain all of the detailed information like numbers and exact code, as well as the chronology can get a bit fuzzy because we're essentially distilling down possibly even an hour's worth of work into a bullet. Within that bullet, there were 3 or 4 different things that happened in a specific order that will not show in that summary unless we specify. But summarization still is top dog because it simplifies a process that can get very complex and is very domain agnostic, meaning summarization, if given to any LLM, it's going to be able to solve it for law, for coding, because ultimately It's solving the same problem of distilling a long session of tasks and to-dos and actions into a nice to read summary. We also use these often with subagents, and subagents are then doing their entire process, and instead of bringing that entire session log over, they usually summarize into a final report that is passed off to the main agent. Summarization works in all sorts of ways across these harnesses today. Then there's the sliding window, which is mostly just the idea that as things come in, things go out. You reach a maximum threshold or some sort of threshold that exists. There's no semantic importance that's valued. You're only valuing time. But there are some situations where it's not necessary to have full semantic context, and actually the chronological context or the temporal context is more important. And in those cases, you might opt for faster long-term sessions that are focused on moving specifically through time, and you have less value for long-term memory. Then you have collapsable context, which is actually kind of one of my favorites because it takes context over time, usually structured outputs, things that are easy to collapse into groups or into types. You're able to collapse similar parts of the session log into a smaller, reviewable, retrievable file it's saved to, or maybe a hint at what tool call to go retrieve that collapsed context. The one note is that it's very specific to things that are easy to parse and collapse procedurally. Otherwise, you're essentially relying on an LLM to collapse context for you, which is honestly just going to take longer than a summary and could possibly be less efficient, since a lot of these LLMs will not consistently collapse contents the same way. But the positive is it's much less lossy. Then the agent can go in, look at whatever those hints are that exist, and dive deeper back into previous context, or use those collapse generations as context themselves. It might say that we've worked predominantly with markdown files over the last 10 turns or something. Therefore, it knows that the context is that it's working in markdown previously. So these kinds of forms of compaction, if specific to the session or the type of work you're doing, can be extremely helpful while retaining a lot of information that it can go back and look for. And then last is living documents. So you see these a lot with like OpenClaw, Claude Code, I guess. It has the Claude MD files can be set up this way, where you essentially have a scratch pad the agent can actively manage as a file to manage its own context. So in this case, it would trigger or be told, or over time, you might have that sliding context, but it's managing its own context memory in a file, or it's saving its own version or view of what happened to something that will persist. So in this case, it wouldn't be summarizing what happened, but instead managing a set of values like in a sole MD file where it's learning over time, and it's skipping the part of summarization, but it's adding the contextual information that would prompt it on the next session. It's very complicated, and to be honest, I think it's a probably very rare case that you would want to use that, because as we have found out in the past, agents are terrible at prompting themselves. Oftentimes they're very bad with meta contextual assignments that involve them managing themselves or managing another agent. It can get difficult, and a lot can get lost in that passover. So when we think about managing that desk, Einstein's desk, that context window, and compacting it and helping clear out some of that clutter, it also matters when we want to interrupt. Imagine going into Einstein's office and being like, "Sir, I know you're probably very busy right now, but I kind of want to start removing some of this stuff. You've got some clutter, you've got your pipes, and you've got all sorts of these documents. Let me move those out for you." I can imagine there are a lot of times when that probably wasn't a good idea, because you might break his flow. He might be working on something important, and then he goes, "Well, now's not a good time." I know I'm like that. The same goes for these agents in a much less anthropomorphic way. They do have a flow or a momentum, and that is the context window or what you throw into it. So having a random compaction in the middle of a project can be totally detrimental when it was on a roll to trying to solve or come to a conclusion. Therefore, it now has to use the summary or the compacted information to then come up with a solution. Therefore, it lost all of the depth and richness of the steps of search and thinking that it got to, or it has to go back and refine that information, which ends up taking more time and more tokens. A context window is a finite space, therefore, you can measure 40, 50, 60% of it, and when those tokens in the context window reach that threshold. So I can say, hey, I know at 40% threshold, it's time to start doing a compaction task of some kind. When I do that, it triggers, it goes, boom. I can inform the agent that, hey, we're getting close to compaction. Some apps like Claude Code do something along these lines. They are measuring your context window. They want to compact at a certain threshold, or they want to start initiating certain memory tasks at different thresholds. So it doesn't have to be one line in the sand. You could say, hey, at 20%, I want to make sure that we're already off to the races on whatever task we need. And then at 40%, we might say, hey, it's time to wrap it up. We're only going to go to 50%. Boom, let's clear it and start over. So these thresholds can be very useful because we know there are certain upper limits to when the model is going to be successful. And if we use something like the Ralph loop, I believe uses something along these lines where it just brute forces through these thresholds until it gets it right, never letting it really get past that later stage threshold or that 50, 60, 70% where you get to the point of diminishing returns. Then there's instruction based, which is, hey, I have a rule that you have to do X and X compaction task at this point. So you're relying on the LLM to trigger or run a compaction task on its own accord when it feels like it's important to do so. I think as your workspace and your code base gets more complicated, this kind of instruction-based compaction can be really helpful because you might be context switching more than you think. And in terms of working with a few different folders or components or different parts of your repository, you might feel the need to run a certain kind of compaction task, meaning a summarization or some sort of clearing of context debt, removing something from the context window, securing or making sure something's complete. That's what I mean when I say compaction task. And the more that these agents become self-reliant, work on long-form tasks over time, it's important that the meta system that it manages itself, if you go that route, it needs to be in on it. It needs to know and commit to whatever the plan is. It's going to know better than any procedural system when the right time to do something like compact or summarize, change tasks, switch contexts. It knows when that's going to be the most effective based on the current trajectory. Unless you're sitting there and managing it yourself and giving it custom prompts and custom instructions, it's best to rely on the agent to self-manage in certain circumstances. And the best part is, if you do use instructions, it's as simple as writing a prompt. You don't have to necessarily write a new tool, not always. Giving it a set of instructions to manage its own context could be as simple as writing a really good prompt. That said, it's a much more complex implementation that does take time and effort to get right. I also think it's important to remember that you can have cron-based or time-based compaction where you think about an OpenClaw instance running over a long period of time. You might want these checkpoints that say, hey, now's a good time to shore up any information, summarize, research, think about something. It might be an easy way to clear off some debt on the back of the context. Whatever it might be, time is a huge factor in the accumulation of context. Therefore, I think it's also important in these long tasks to think about how can time play a role in the compaction of context. The last part is the retrieval method. How does Einstein, once I clear his desk, go back and get any of the work he needs? Compaction isn't about the destruction of context or the removal. It's also the way that we manage context for the agent so that it can always come back and retrieve it. There's been many times when I'm in Claude Code or something along those lines, and it needs to go back and look at previous session logs for context. Or times I've gotten frustrated, cursed it out, and said, hey, God damn it, how do you not remember the thing we did this and this time ago. And you could refer to session logs or Git history or summary files that are stored in a document. It's not enough to say that compaction is only a transition between two sessions. It is the accumulation of transitions across multiple sessions. So there's the file system. You store everything in the local file system in the workspace. It can go back, it can retrieve anything by just querying the session logs. It knows where to look. You can point it to a folder where we store raw data or we store some sort of summarized data. And that usually involves putting a little map somewhere for Einstein or your agent to look and be able to retrieve and know where things are. That way the retrieval of context is as simple as a few lines of code, some file system paths that exist in the code base for it to go and retrieve something. That is often enough for it to use some sort of bash call to find or query or look at real files with real data from previous conversations if it needs more depth or richness. That said, it does bloat up. You could have huge amounts of bloat, and there's nothing semantically tying together what the agent is looking for versus what it actually needs. You might be thinking, hey, why not RAG? I can also query and say, when was the last time we were talking about giraffes? And Einstein can just pick up the phone and say, hey, yeah, we were talking about giraffes for quite some time. What was that all about? Based on that query that the LLM gave us, find semantically similar session logs or semantically similar session data that we've generated or summarized and connect to it. You could even inject semantically similar data into the context window without the agent even calling it. While that is much more riskier strategy, it is possible to think about using real-time session logs to fundamentally shift the context window of previous sessions based on the semantic similarity. Now, I don't think I could work this way, but a nudge every once in a while can be super helpful. I feel like even for Einstein, he had people there to help direct and push him in the right direction, people to glean ideas off of, and for LLMs, they often rely on us to be that person to help nudge them. That said, we're not always going to be there. And the longer we extrapolate out these sessions, the more we're going to find that we need other systems to help nudge it in the right direction. So in some cases, you can use things like linters or language server providers. You can use other models or other agents that are helping orchestrate. These are all ways that a nudge in the right direction that is minimal context, but a highly actionable piece of context to tell you to do something or look in the right direction. We can train these other models to help nudge the main model in the right direction. That said, it requires a lot of training data if you want to go the model route, or you're working in a very specific domain where procedural systems can help nudge in the right direction. And last but probably least is colocational. I only say least because there's a lot of discussion about agents.md files, which are a form of colocational context, not being up to snuff in terms of helping these agents over long horizons. But there are use cases out there that are worth exploring where when an agent is in a certain location, meaning a certain file or folder or working on a certain thing, everything that's similar should be around it, or everything that is related to that space is going to be in that location. Just like you're in an IKEA, if I go in and I'm shopping for a bed, I'm in a bedroom with drawers. In that metaphor, we are co-locating objects that are similar so that it's easier to go buy all the right things for your new bedroom. An agent's going to walk into a folder. There's going to be a lot of subfolders and files. We can hot swap the context so that it's better suited for that specific thing. One of the problems that you could foresee with colocational context is that as soon as an agent exits a folder, it's also losing context in whatever new folder it moves to or its work proceeds in. I could have two different folders, and the folder structure or the area in the code base could be vastly different. And depending on how I structure my code base, it could get way more complicated than I imagine, trying to pair session histories and summaries with where the agent is in the code base at any given time. Some might be more relevant in another folder that it's not in. Compaction exists because of our limitations of using these models. So naturally, we're going to keep trying to find ways to make it work. I like to think of microchips as very analogous. A microchip has to keep getting smaller and smaller and smaller while still retaining or even improving on the speed and efficiency of the previous bigger model. So with compaction, we're always looking for systems that can help us reduce the amount of context in the window at a given time while still remaining lossless in the idea that it can retrieve and get that information. So retrieval and compaction are highly integrated systems, or at least need to be. And take a look at your own desk. Think about how you manage your own life. I'm sure you'll find efficiencies and ways that you prefer a messy desk versus a clean one. It's possible that you find certain messy items easier to filter through because I don't want to lose that context. I want to keep those bills on my desk because I need to pay them. I don't care if they're there all the time. I need to pay them. So you can understand that the same goes with these working contexts for agents, where there's certain things that you just want to keep in the context for security. You want to keep something in context because you don't want to lose the thread on something. If you have any questions or ideas for the next video, hit me up on Twitter, hit me up in the comments down below. Tell me what you're interested in. Until next time, stay curious and stay shiny.